Okay, here we are with inverse trig functions integration part 2. And from this scenario, when we think about integration with trig functions, you have to recognize that it's going to follow either this form of arctangent, where it's a squared plus an x squared, or it's going to do arcsine, which is a square root 1 over the square root of a squared minus x squared. That's the arcsine scenario. And since this particular scenario has no square root, it's going to be tangent, but this does not match to here. And so what I need to do is I need to complete the square of the bottom of that fraction. So if I rewrite this, I'll pull the 3 out, because it's just a coefficient, and it's 1, and I'm going to complete the square. When I do that, I know it's x, and this is going to be squared. In order to complete the square, I take half of this value and I plug it in here. And now there is a plus 5. Here, when I've completed the square, in essence, I've added a 4, meaning 2 squared. That's the last term inside this calculation. I've added 4 to it. I've added 4, so that means I have to take 4 away as well. So now the bottom of the fraction is equivalent. And so with this completed square, I have minus 4 because there was a plus 4 added there. Don't forget my dx. Oh. And so if I simplify that, I get 3, 1 over x plus 2 squared plus 1 dx. Now, this is in the form of this because adding the order doesn't matter. And so if I do the integration, it's 1 over my a value is the square root of 1, which is 1. Arctangent. Well, here is my x value, x plus 2 over 1 plus c times my 3. And I could have done a u substitution here, and u would have been x plus 2, but the derivative of x plus 2 is just dx, so there's no coefficient from the x plus 2 to deal with. And so my final answer is 3. Arctangent x plus 2 plus c. Another example now. We have arcsine in our our integral and the square root of that. And so that arcsine x is messing with me a little bit. And if I think about my derivatives or my integrals, I know the integral of 1 over that is arcsine. So the derivative of arcsine is that. What I'm really seeing is not an inverse trig function, but a u substitution. If I let u equal arcsine of x, then du, the derivative of arcsine of x, is 1 over 1 minus x squared, all square rooted dx. That's the derivative, which is in here. And so I can rewrite this as arcsine is u. The dx times 1 over root 1 minus x squared is equivalent to du. There is no fraction left, or it's over 1. And so taking the integral of u is quite simple. It's 1/2 u squared plus c. Plugging in our u value, my final answer is 1/2 arcsine of x squared plus c. There's my answer, and I have to be careful that it is a u substitution. And one of the hardest things about integration is choosing the right technique to help us out. So question 3 here, we know g prime is 3 over 9 plus 4x squared, and we want to find g of x where it contains this point. This looks to me to be the form of arctangent, because it's 9 plus 4x squared. So if I consider this, and if I rewrite this, I know I'm looking for the integral of 3 over 3 squared plus 2 squared dx. That's a rewrite of g prime. Let's go to skinnier pen. Well, in order to do this scenario, I know I'm going to pull out the 3, and I'm going to let u be 2x. And so du is equal to 2 dx. This is going to be my u value, so I can cleanly integrate. And so there is no 2 over here, so it's 1/2 du is equal to dx. So the 1/2 I'm going to put out front here, and I have 1 over 3 squared plus u squared du. So 3/2, using my formula, there's the 3/2 from here. 1 over a is 3 times 1 over a arctan u over a. But I'm writing a, but I know a is 3. A is 3 plus c. And so substituting back, I know that g of x then is equal to 1/2 arctangent of 2x over 3 plus c. Now I need this point here is to help me find the c value. Here is my point. I take that value and I plug it in, and so 3 pi over 8 is equal to 1/2 arctan of 2/3 times -3/2 plus c. Convenient that this is so. So it's equal to 1/2 arctangent of 1 plus c, -1 plus c. Well, this question here, arctan -1, is asking what angle produces a ratio of -1. So where's tangent -1? Well, that happens at negative pi by 4 plus c, 3 pi over 8. And so I have negative pi over 8 plus c is 3 pi over 8. So c is equal to 4 pi over 8, which is half pi. And so putting it all together, g prime, or g of x, is equal to half arctangent 2/3 x, 2/3 x plus pi over 2 is the final answer of the function.